All right, so I'd like to thank everybody for joining me today. So I just want to put on a little quick training session on kind of the basics of Muck 3D, Muck 3D Tailings Plus. Just go over, general overview of the software for anybody that's not familiar with it. Um, start in Catapult, talk about launching the software, take a look at the interface. Then from there, touch on data import. So a lot of common, situations that you guys are going to be in. You're receiving data from your surveyors, you're receiving, design work. How do you get those files in? How do you export them to a compatible file type, maybe to put it in Civil 3D or something else? Then from there, look at the dynamic modeling tools within Muck. How to build a dam structure quickly, a road, an excavation, a ditch, a dump, um, how to, merge those into the grid quickly and kind of work with that topography. And then from there, take a look at, you know, deposition, a different type of deposition modeling tools, some capacity based, some schedule based. Maybe you're trying to figure out, what's your maximum amount of tailings that you can place in this facility based on some specifications you have, or maybe you have a production schedule and you're trying to see, with those volume targets, what elevation you're gonna hit in terms of, that contact point on your upstream dike. If you guys have any questions, please put them in the chat. Um, I'm not sure if I'm gonna have time to touch on everything, but if there's any time left, definitely want to touch on something, or if there's something that maybe was glossed over too quickly and you guys want to review, please let me know. I'll just open the chat now and share my screen. Okay, so I'm going to start here in Catapult. So for anybody unfamiliar with this version of Muck 3D, it is launched through Catapult. You don't run Muck 3D directly. You launch Catapult, and then from there, um, you can enter into the software. Now, this is going to change with the upcoming iteration. You're just going to, run Muck directly from the shortcut. You can see it here, but for this version, you're still in Catapult. So Catapult has, your licensing tools, diagnostics. If you want to launch the web admin, that's all found here. As well, a list of all your existing projects that you've recently used will be in this project section. You can start a new project by hitting this button, or if you want to go look for a specific project, you just hit this, go to the from disk, and then you can go find that PRJ file and launch Muck. Okay, so one thing that's really, I think, practical to remember is sometimes you'll be in Muck, you'll exit out, you'll try to go back in, and your license will be occupied. And you're thinking, okay, well, no one else has jumped on the network, in the 5 minutes that I've exited the project, but my license is still tied up. Sometimes you don't get a clean break out of the software, so instead of having to do Control-Alt-Delete, finding that muck3d.exe file running and, ending that task, just hit this X here. You'll notice that if you're still in the software, this X here is going to be red, and if you hit it, that's going to force restart and free up that license. Also, if the software freezes for whatever reason, you can also just hit this X and exit out of the software quickly. Okay, for anybody that does have a license right now that's following along, I'm just going to start by creating a demo project. So Muck 3D does come with some pre-established demo projects with some pre-existing data. So I'm going to go here up to this button. I'm going to create a demo project, and I'm going to go to golden banana copper. Okay, so it's asking me where I want to save it. So I'm just going to put it in my Muck 3D project directory and what I want to name the project. So I've probably loaded multiple golden banana copper projects at this point. So I'm going to just put a 9 here to make sure it has a unique name. Choose my license and launch the software. It's immediately now that the software is launching, that X button is now red. And if I hit that, I will exit out of the software. Okay, so this is the 𝐓𝐸3D interface. You'll notice up top the version that you're working with, your project directory here. You have your different toolbars here, or your different drop downs for the different tools within the software we're going to get into today. Shortcut buttons up here in your toolbar, and then your different windows. Okay, let's start here with the Project Explorer. So the Project Explorer is your file directory. It appears and looks as it the same as it would inside Windows. So these are all the project files that you have. And you can see here within this base folder, this Golden Banana Copper project has, at least 13 surface already loaded in. So this is where you can create new directories. So if I just right click within the Project Explorer, I can show this in Windows directly. So I hit this button, it's going to take me to Windows to that exact database file folder. Up here, I have a file filter. So if I want to look at specific types of files, maybe I only want to look at 𝐓𝐸3D files, image files, storage elevation curves, it'll filter those out. So you'll notice that at least 13 surface file disappeared. And if I go back to all files, it's there. It's just filtering different files. In case you're looking for something specific, always beware. You can definitely be in a situation where you've put the file filter on and you don't realize, and suddenly you can't find a specific file that you're looking for. So within here, any new layer that you create, that you save, is going to be saved to your working directory. To set a specific directory to working, you just have to right click on it and then choose Set Working Directory. You can also create new directories by right clicking on it and hitting OK. And you have the option when you create a new directory to set it immediately as your working directory. You can also do things like if you want to launch the command prompt to that specific folder, you can do that. And you can, work in that way for whatever reason. Some practical functions within the Project Explorer. Let's say I want to move this least 13 file to my new directory. I can right click on that item and I can copy or move it to the working folder. So I'll just copy it, and then you'll see it's both in my base directory here and in the new directory, which is the working folder. Let's say you lose track of your working folder. You don't know where it is, where that working directory is. You can hit this button here, and it will highlight it and bring you down to that subdirectory and open it up. And you can add files to your favorites. Call this topo. It's going to be my tag for the category. I'm going to add that least 13 M surface to my favorites, and then it will come up in my favorites dropdown over here. If you are constantly referring to specific files, I want to go back to them on a regular basis. Okay, so the Project Explorer contains your saved data. It exists there as it exists on your hard drive or on your network drive. If you want to open it, there's different ways. So I can take this least 13, I can just drag and drop it in to my 3D window here. You can see a surface will appear. Also, along with the surface appearing in your 3D window, it's also loaded now into your scene manager. So your scene manager is, itemizing, listing all the layers that you're opening within your 3D window. Within the scene manager, you can make them visible or non-visible. If you want to unload the layer, you just have to right click and go to unload this. It'll disappear. Beyond just dragging and dropping it in, you can just double click on a layer and it'll open as well. If, however, I try to right click on a layer here and hit open, it's going to try to open it as if I'm in Windows or I'm in, File Explorer. So it's not going to work in most cases for Mach3D files that you're trying to view within the software. If this was a CSV file or a JPEG that you also have loaded in here, then it would open. I think I just tried to open it with Notepad. Okay, in the scene manager, let's say you lose track of your surface. You can right click on it and go back to zoom to layer. You can change the colors. You want to make it green or blue or black. In this case, it probably looks by far the best in white, which is the default color. You can change the opacity of the surface. So this is its transparency. Let's say you're working on a project. There might be a point or a line that's hiding behind your surface. You want to manipulate that line while still, having that surface visible. So you can change the opacity here. You can make it 50%. You can see it's a little more translucent. You can see through it. Go 25%, it's fairly transparent. And if you want to go back to full, visibility, you can just go make opaque again. Okay, just in terms of the functionality within the 3D window. So I have my surface here. If I want to zoom in on it, I just roll that wheel on the mouse. If I want to tilt in 3D, kind of change my view in that way, I just hold the left mouse button down and then rotate the mouse, move the mouse a little bit. If you want to pan left to right, east to west, north to south, just hold that right mouse button down and then move your mouse. So tilting, left mouse button, panning, right mouse button, and then just zoom in. Let's say you're in a tilted view and you want to go back to plan view, hit P. That'll take you back to plan view. If you're in tilted view, you don't like the zoom level, you want to go back to that original zoom level, original plan view, hit R on the keyboard. You'll notice as I'm scrolling my cursor over the surface, on the bottom left-hand side here, I'm getting the coordinate information of any point that I'm above in XYZ. If at any time you want to note the specific coordinates of a specific point where your mouse is located, hit C, and that's going to copy those coordinates to your clipboard. So, and then you can just paste them if you'd like, and we'll utilize that later. Okay, other windows. You have here your output window, and this is where any information that you're trying to ascertain from the software is going to be published. So, if you're trying to get a volume, when you're doing deposition runs, trying to get, a pond area, that's all going to be published in your output window. I'm just going to quickly check the chat here. I see there's a question. Who is going to provide us with this least 13 file for our analysis? So in Catapult, there's demo projects. So if you select this golden, thank you. Yeah, so you just select that demo project and the least 13 file will be available to you. Okay, so your output window has all the information that you're trying to get out of the software. It's what's communicating with you. So if you run a volume, you do a deposition run, any type of interaction on that level, it's going to be published to your output window. Over here, you have your dynamic model properties window. And this is going to show you, you know, the inputs and outputs for the various structures that you're building, a dam, a pond. That's going to get listed here. We're going to take a look at that when we do some structure modeling, and you'll be able to interact with it and change the inputs and see how that affects the outputs. Okay, in terms of the undo redo section here. So this allows you to make changes to layers if they're unsaved, and have them as they were in previous iterations before you made modifications. So I'll just display that quickly here. So I'm just going to draw a line. I'm going to call it line. I'm just going to set it at a consistent 100-meter elevation. And I'm going to turn the guide off for now. I'm just going to draw a line over here, put a few points. Okay, now I'm going to modify the line by moving the points around. I go to polyline, move point on line. Point here, move a point there, move a point there, move a point there. Then when I'm done, I'm going to hit spacebar to redigitize it. Once again, I'm going to hit T. Not once again. I'm going to hit T on my keyboard here to make this surface transparent. So the shortcut key, instead of going through this process of changing the opacity, I can just hit T directly and make the surface transparent. Or not. So now I can see the points hiding behind the surface. Now, if I want to go back to the original version of that line prior to moving around, I go to this undo redo tab. I can hit original and I'll go back to how it was. Or I can select this version. And as long as you haven't saved it, you should be all the different versions of that layer will exist here, and you can select which one you want to finalize before you save it. Now, speaking of saving, you'll notice here these layers are now in bold red font in my scene manager. This is because I've modified them. I made the least 13 surface transparent. I've moved the points on this line. I just created it. I never saved it in the first place. So the bold red font is letting me know you have layers in your scene manager. You're working with layers in your 3D window, and they remain unsaved. So as soon as I save this, it will go back to normal font. If once again I change the opacity back to opaque, that's a change. And it's bold red font again. Okay, so I still have an unsaved layer here, the line. If I right click in my 3D window here, I can see a menu comes up. I have the recent commands I've used up top. And then I have some staple functions down below. Finally, the clear graphics. So if I just want to clear everything out of my 3D window, unload all the layers from my scene manager, clear graphics. But you have to be careful because if you haven't saved your layers, it will remove them from your scene manager, but it will prompt you before. So it's asking me, okay, you have changes, made changes to these layers. Are you sure you want to clear everything? I do. I'm going to discard everything. Everything from my 3D window is gone, and everything from my scene manager has been unloaded. Okay. Let's get into some data import. So I'm going to create a new folder. I'm going to call it data import. Instead of my working directory, and I'm going to explore here. So I've opened this folder in Windows. I'm just going to grab some data. You guys don't have this data, but you can follow along. And I'm just going to drop this into my data import. So I have my import subfolder, and this contains some geotiff data, some LiDAR data, some DXFs, just to show, how different file types get imported within Muck. Okay, so probably the most common file type here, DXFs, DWGs, very simple process to importing them into Muck 3D. You can just drag and drop them directly. There's full compatibility here. I can take this DWG, the highway design, just drop that into my 3D window. And you can see it'll come through. Taking a look at the surface here. Another shortcut key. If I want to go from not having a continuous smooth surface that's tinned through, I can hit W and it'll go into wireframe mode. And then you can see, how the surface is constructed, the different nodes, and how they're triangulated. If you want to go back to a smooth continuous surface, just hit S. So really easy data import for that DWG. Same thing for the DXFs here. You can just drag and drop those in. If you want to convert these, or if you want to get a sense of, what file types are compatible, just right click on a layer and save it. So I can see I've imported this as a DXF. I can save it again as a DXF, or I have all these different types of files here that you can just transfer that in directly. So there's no special process to convert from one file format to another. In this case, you can just import directly and save directly. So if you have some line work that you've made in Muck, where the native file format would be an M-curve, you want to export that as a DXF, just right click on it in your scene manager, save it as a DXF, and then you can, import that into Civil 3D or, your other softwares that you're using. Once again, right click on my screen and clear my graphics. I haven't made any changes, so it just unloads everything. Okay. So you've received some LiDAR data, some survey data. You have, an LAS file here. So the first thing I'm going to do is I'm going to go to my data import menu in LiDAR, and I'm going to inspect that LAS file. Just going to take a look at it before I try to import it, just to see what I'm working with. Before I do that, though, I'm going to make this LiDAR folder my working directory. It's just going to make things easier if I'm looking for files in a specific folder, if I make that folder my working directory. Because when I go to data import, LiDAR, inspect LAS file, and I hit this file name button here, it's going to take me directly to my working directory. So it just saves me time versus, looking for that file in Windows Explorer. Okay, so I'm going to select this, about 20 megs, and hit OK. You're going to see here in your output window, it's going to give you information on that LAS file. Okay, so I have about 72,000 points. I have the dimensions, and I can see here there's multiple classifications within that LiDAR file of the survey data that's been picked up. Okay, so if I just take this LiDAR file, I can just drag and drop this LAS in. You can see it's brought in a bunch of points. All right, so I'm just going to go ahead and make a surface from these points. It's kind of warned me, there are multiple classifications of survey data here. This isn't all necessarily bare ground. There might be some other stuff, but I just want to take a look. Okay, so I'm going to take these points. I'm going to go to surface, create surface from layer. And this function is going to use layers that are open in your scene manager. I'm going to pick the source data. It's looking for layers in my scene manager. There's only one. You can use that. I don't have any break lines. I don't need to constrain it to an area. Just going to OK. And I'm going to notice here, a surface has been created. Oh, what? It's like accidentally closed. I'm just going to open up that up again. All right, let me try that again. Surface, create surface from layer. I choose that layer, create my surface. I'm going to toggle off the visibility of the points. And I'm going to take a look here. Okay, so I have a pretty good surface. If I look at this area here, this doesn't look quite right. It kind of looks like it's trying to digitize potentially trees that were there. So I'm getting the bare ground and I'm getting top of trees. That's what that looks like to me. So when I inspected it, there were different classifications of data. I imported everything all at once. I tried to make a surface. So that probably wasn't the appropriate strategy here. Okay, so I'm going to clear graphics. I'm going to import this again, but this time using the import LAS function file. I'm going to go find my LiDAR file. Okay, it's brought in 722,000 points, and it's classified them for me now as that survey data was picked up. So I don't want unassigned. I don't want low points. I don't want water. I don't want rail. At this point, I'm just really interested in the bare ground as well. At this stage, if, this number was 48 million or even 4.8 million, probably wouldn't want to import all those points at once. Maybe you don't need that level of detail. You have the option here to you can preview the file. This is basically you're thinning the data. Right now I'm choosing to thin it by a factor of 10, but you can do that by a factor of 2 and just bring in half of these points. As well, you could bring in all the layers simultaneously, and it would just create separate layers for them. So these would all get imported on a separate layer. So I'm just going to preview the file by a factor of 2. Only bring in that ground data, and then retin that surface. So it came in pretty fast. This already looks better here. I'm going to go once again to surface, create surface from layer. You'll notice in the toolbar menu, at times, certain functions will have icons beside them. This is because these are shortcut keys. You can see that surface from layer button is right here. I'm going to pick that surface, turn off the LAS file, take a look at that area again. It looks a lot better because I've only imported the bare ground. I go W here on my keyboard. I can take a look at the tinning. And you can see here, based on how this is tinned, the size of these triangles, this looks like water to me in these areas, which is why I didn't pick up any bare ground. It just tinned right across. Because there's no bare ground here, it hit water. Okay, well, I have 2 new layers, both in red. I don't really need these for the rest of the training, so I'm just going to clear my graphics again. I can discard all. Okay, let's take a look at some TIFF files. So again, I'm going to go back to my data import menu, GeoTIFF, and I'm going to inspect GeoTIFF. Once again, make this my working directory first. I'm going to find this DEM TIFF, hit open, and once again, take a look at what I'm working with. All right, so you'll notice in the menu here, and I should mention, these windows are all dockable. So you can just move them around, put them back. Sometimes quite practical to undock your output window. Just resize it, take a look that way. If you want to turn 3D windows or toolbar components off and on, you can just do it by right-clicking on any of the 3D window banners and hitting or deactivating these check marks. Okay, so in terms of this TIFF, it's giving me my coordinate reference system, UTM zone 12 north, and it's also giving me my point count here. So I'm dealing with what appears to be 3.9, almost 4 million points. It's a fairly large surface. I don't know if I want to bring that all in at once. If I take a look at the other TIFF, which was the ortho file. So here I have the survey, the DEM, and then the satellite imagery. Same coordinate reference system. Look at the number of points on that, and that appears to be 22 million points. So I definitely don't want to just bring in 22 million points of ortho imagery. I'm going to have to process that in some way to bring it into the software. Okay, so I'm going to go back to data import. Let's start with the DEM here. I'm going to import GeoTIFF. I'm going to pick my DEM. I said 4 million points. That's more than, I want to import all at once. So I'm going to thin it by a factor of 5. I'm going to choose not to reproject it. I'll leave it in its native coordinate system, and then I'm going to hit OK. Okay, so resampling it by a factor of 5 worked really well. That imported, immediately. While I have this open, I'm just going to quickly create a small rectangle. Put at elevation 400 so I can see it above the surface. And then I'm just going to save that to my working directory. Okay, so I've imported the data. It is thin by a factor of 5. I'm working with the surface right now. It's running pretty well. But what if, there's something in this specific region where I want all the detail? I'm going to unload that DM layer. Right click on it, unload this. Now I'm just going to bring in survey data or that DEM within this area and at full quality. Go data import, GeoTIFF, extract region from GeoTIFF. I'm once again going to choose that DEM. I'm going to call this extracted.tiff. So it creates a TIFF. I'm going to pick the geometry for bounds, which is this rectangle that I just drew. like the mcurve file, not the mdrawable. And here, once again, you have the option to thin the data again. So if I wanted to bring that in at 50%, 25%, I could do that. So you can extract and thin the data simultaneously if you want. In this case, I'll bring it down 100% and just within this area. Okay, it's created a new TIFF to my working directory. Just take this TIFF, drag and drop it in. And you can see here, I have that region with the original point spacing. I'm a little curious. What is the point spacing on this TIFF that I just imported? So for that kind of information, go to info. So you have the different types of layers here. In this particular case, I'm looking for grid information on my TIFF. I want that grid info. Select my grid. Once again, in the output window here, I can see that TIFF was picked up at a 0.5 meter grid spacing. So when I resampled it by a factor of 5, I would imagine at a 2.5 meter grid spacing. But still, just in this small area, I'm still dealing with 206,000 points. Okay, so that's how to deal with, larger grid, topographic survey DEMs. Okay, so what about that satellite imagery? Clear my graphics here and take a look at that ortho. Okay, so for orthos, you want to be using the functions in the text menu, in the text, import, and these functions right here. So when I inspected it, I think I had, 20 million points. I definitely need to resize that to be able to work with it. If the file was of a sufficient size, I could use the convert image function, and I could just convert it directly. I think in this case, I'm going to have to start by resizing a georeferenced image just to bring that size down, and then I can work with it because it's quite large. So I'm going to resize the georeferenced image. I'm going to go pick that source ortho here, the TIFF. And I'm going to convert this TIFF. I'm going to thin the information and convert it to a JPEG that I can work with. I'm going to call this ortho modified.jpg. And I'm going to be conservative here, and I'm just going to take 20% of that full data set. I'm going to hit OK. Okay, now this has created 2 new files in my working directory. So these new files that are being created, they're going to be written to your working directory. So important to, know where your working directory is. Otherwise, you will get information going to different places. Okay, so there's 2 files here. So there's the JPEG itself. This is just a JPEG file of the image. I can right click on this, open it. Show you the image as it exists. If I want to work with it in Muck, okay, so to begin, I want to import this into my 3D window. If I had a surface open, I could drape it on top of it. I don't have a surface open right now, so I can just view this as a 2D tile. I'm going to hold Control down as I drop this in. And you can see you now have a satellite image that you can use. Okay, let's say I want to clear my graphics. Very easy to drape imagery onto topographic surfaces if they're aligned. Okay, so I'm just going to re-import my DEM surface. I'm going to resample this by a factor of 5 again. Okay, so I have my topography. I'm just going to drape my satellite image on it by grabbing this 𝐓𝐸𝐬𝐬 file, and I just drag, drop it into my screen. This time, don't hold Control down. Select the grid I want to drape it over. Then you can see here you have topographic surface with your satellite imagery draped on. Because I'm draping the satellite imagery onto my topographic surface, it is now a quality of the DEM. You know, it exists on the same layer. It's just basically a coloring of the DEM. So if I come here, I change this back to white, you lose that image draped. Also, the satellite image isn't imported into the software as a separate layer. It's just a quality that you're ascribing to the DEM. Okay, let's say once again, I want to bring in that ortho DEM at full quality, but just a smaller region. Go to text, import, again, extract from georeferenced image. I want my original ortho, TIFF. I'm going to call this extracted ortho.tiff, which is a new layer I'm creating of just a portion of the original ortho. Once again, going to confine it to that rectangle that we drew called curve. It is multi-band data based on the information from the inspection. And I'm still a little concerned about the size of this file, so I'm still just going to take 50% of that image. I'm going to hit OK. And once again, it's created new files, written them to the working TIFF directory. And you can see here I have this extracted ortho.tiff now, which is satellite imagery of just that area. So I can come here now. I should have just directly converted this to a JPEG instead of converting it to or extracting it into a TIFF and then converting afterwards. So I want to redo that. Okay, so I want to redo something. I go to my 3D window, I right click. All my recent commands that I've used pop up as well as these staple functions. So this one I just used, extract from georeference image. I want to do that again. Okay, I want to essentially do the same thing, except I'm going to change the suffix on the file from .tiff to .jpeg. If I want to redo or reload inputs that I just put into a specific function, right click once again on a cell and go last value for all fields. So here, instead of calling this .tiff, I'm going to call it .jpeg and run it again. Okay, so now it's created that JPEG file. More importantly, it's created that 𝐓𝐸𝐬𝐬 file that I can now just kind of drag and drop while holding Control to take a look at this satellite imagery in that area that I just extracted. So different ways of getting data into the software. Large GeoTIFF images, large TIFF DEMs, LiDAR data, DXFs, DWGs. Very easy to, get data in and then just save this under a format to get it out. Namely, exporting things as DXFs and DWGs. Okay, let's move on to structure modeling here. Okay, so I'm going to bring in my least 13 surface. I'm going to work with this one. So I'm going to put my output window back. All right, so within Mach3D, you want to be working with grids as your base topographic surfaces, or your I guess it's confusing wording. When you have topographic data as your base, and you're digitizing designs over it, you're pouring tailings, that base needs to be a grid. Know that because, well, one, it has the M surface file type, but if I hit W here, you can see this is not a regularly spaced network of points. These are points that are, been picked up and are triangulated together. So I just want to convert this surface data into grid data, and that's much more efficient for the software to process and allows us to do, a lot more work faster. Okay, so I'm just going to go to grid here, create grid from surface. I'm going to select my surface. I'm going to call it lease 13 grid. At this point, it's asking me, when constructing the grid, how far apart do you want to space those grid points? Right now, it's set at 10 meters. So there'll be a point every 10 meter. So your base topographic topography will be made up of a network of points spaced by 10 meters. That might be a little too sparse. It's also telling you, at that spacing, we're going to have 93,500 points. Okay, well, what if I do every 1 meter? All right, well, that will create a grid with 9.350 million points, and it's letting you know, while there is no hard limit on the number of grid points, using a grid with this number of points may cause some issues. This includes slow memory to run, memory limitations on 32-bit Mach3D installations, issues with graphic cards, and others. So essentially, this is too much. There's too many points. At 5, 374,000, it still works. At 2, it's still red. At 3, it's still red. At 4, okay, you're getting into orange territory. It'll probably work, but it might slow down slower machines. So I'm just going to go with 5 and hit OK. I can see here it's created a new grid layer. If I turn the visibility of my surface off, it looks essentially the same. Slight differences based on taking the surface data and then reconstructing it into an evenly spaced grid. If I take a look at the grid in wireframe mode, you can see the difference from the surface, as you now have points that are regularly spaced. Okay, I'm going to turn off my surface layer. I'm going to unload it. And I'm just going to save my grid. But before I do that, I'm going to save it to my base directory. So I'm going to make that the working directory. Okay, let's build a dam shell to start. Before I build the dam shell, I want to get a quick sense of, okay, what elevation should I be constructing this dam? It kind of looks, based on how this grid looks just, in plan view, this seems to be a low point here. There seems to be a valley. I think I want to dam off here, but I'm not quite sure. If I go to apply style here, there's different options. I can, apply a color style, a texture, but namely an elevation style. So I can take this grid and quickly apply an elevation style to get the range of elevations across it. Okay, I'm going to choose this Atlas one that's pre-made. And then I can see with the histogram, based on the coloring here, the range of elevations. I'm more of a higher elevation is warm color, lower elevation is cold color guy. So I'm going to edit this elevation style. So I'm going to hit this button over here. It's going to bring up my style manager. I'm going to look at the elevation shader section. I'm going to find this one that I'm using right here called Atlas, and I'm going to edit it. If I wanted to add a new one, I could just right click here, add a new one. In this case, I'm going to edit it. Okay, so I can see this is going from 0.00 to 0.667, basically red to blue. So I'm going to swap this, swap the hue start, just dictate the colors. I'm just going to invert them. I'm going to hit OK. Hit OK again. It's going to flip the color scheme for me. So now low elevations in blue. Not important, but just in case you want to know that. And this counts as a change to layer, so it's now bold and red. Okay, so I can see here, 400, 425 meters. Probably a good elevation for the dam. I'm going to go to structures, dams. There's different ways to create dam structures. You can draw them quickly by digitizing a line and then forming the shell from that. You can create it from pre-existing line work, whether that be a center line or a downstream toe. To begin, let's just draw a dam quickly. All right, so I'm going to choose to draw the center line of the dam crest. I'm going to put the crest elevation at 425 meters. Crest width is going to be 20 meters, left slope 3-to-1, right slope 2-to-1, and the shell height, I'm going to make that 100 meters to start. And I'm going to ask it to calculate the volume. So after I'm done digitizing the shell, it's going to create the model, or it's going to calculate the volume for me, and I'm going to choose initially to not create a dynamic model. Hit OK. It's asking me to select my base grid. When the software is interacting with you, there'll be a red highlighted bar down here, letting you know what it wants you to do. And then whenever you're within a function or a function is running, there'll be a highlighted green bar down here. So I'm in the drawdown function, and it's asking me for something to select my base grid. I want to draw it over this base grid. And you'll notice a, semi-transparent red plane has appeared. This is the elevation guide. It pops up, when you're drawing lines or in a lot of different functions. In this case, I'm drawing a dam. I'm drawing a dam at 425 meters in elevation. So it's letting me know with this red plane at 425 meters in elevation of within the grid that I'm working with, what is above, what is below 425 meters. So all this area in here that's shaded, that's below 425 meters. All this area above, all this area here that isn't shaded is above. So it's essentially letting me know this would probably be a good spot for my dam. So I digitize the point in here, and then I just continue drawing my line. And you can see here it's creating that shell for me as I'm drawing it. So I'm just going to put another point here, left click. I'm done. I'm going to hit spacebar. And it's created some new layers for me in the scene manager. Well, one, there's the grid. It's always existed. You can see here it's created a dam shell. Created the center line that I drew at 425 meters. The shell itself, and then break lines. Does look like I added a third point here erroneously. So I'm just going to redraw this quickly. It looks a little cleaner. Once again, right click, draw a dam, right click, last value for all fields. Hit OK. Select my base grid. Put a point here, put a point there. I'm creating layers that, are named the same as existing layers in the scene manager, but I do want to overwrite them. All right, so that's a little better. Okay, so it's created some new layers here. It's created that center line, the dam shell itself, and break lines of the surface that you can see here. So the shoulders of the crest and the toe of the unclipped shell. Okay, so I have a volume here that I calculated for me in the output window, 6.983 million cubes of fill to build this particular structure. If I wanted to run that otherwise, let's say someone just sent you a shell or sent you a surface, you wanted to run it against topography, you just go to grid, volumes, then you have your different volume tools, net volume between grids if you have two topographic surfaces, bounded volume between two grids. So you got two topographic surfaces and an AOY. You want to restrict the volume to that area of interest. Volume between grid and a surface. That's our situation here. So I'm just going to run a volume between this grid and the surface. This is a fill volume that I'm interested in. The only thing that's really important here is volume above the topography. So I'm going to hit OK. I'm going to select my grid, select my surface. I can see here, I get the same number, 6.983 million cubes roughly. Okay, let's say I wanted something a little more detailed, segmented in vertical increments. I'm going to go to grid, volumes, create peels between grid and a surface. So this is going to create a CSV file with all this volume data. I'm going to call it peels. I'm going to go in 5-meter increments. And once again, I want that fill volume. I select my grid, select my surface. I can see here, it hasn't listed the volumes in the output window, but it's created this CSV called peels. So I'm going to right click on that CSV and I'm just going to open it directly. You can see here, it opens the Excel file. Formatting here. And then in every 5-meter increment vertically, it's listing the amount of fill in that increment and the cumulative amount of fill in volume. You can see here, same value, 6.98 million cubes, and then in different iterations. So there's fill in this case between 343 to 428 meters in elevation. And, you can set this increment to whatever you like, depending on, how granular you want to get. Okay, so that's just, running a simple volume between a grid and a surface. Okay, let's do that again. This time we'll create a merged dynamic dam model. I'm going to unload these layers. I don't need these, but I'll keep my grid open. Then I'm going to go to structures, dam. I'm going to draw a dam again. Last value for all fields. I'll save all of these. And I'm going to choose to create a dynamic model. The one thing I want to note here is the shell height. Okay, so we have a shell height of 100 meters. So that is the distance that it's projecting down from the crest to create the toe. So you always want to make sure that you have sufficient shell height such that your crest or such that your toe is below the topography. Otherwise, it's going to leave a gap between, the structure that you're creating and the surface, and that is going to compromise your volumes. I select my base grid. And I'm going to draw this across here. Okay, so it's created new layers. Namely, let's take a look at them. I'm going to turn off the visibility of my original least 13 grid because it's created a new grid, a merged grid. So it's taken that structure that we've built, that shell, it's clipped it, and it's merged it into the topography. It's also created the center line that we drew, the unclipped shell itself, along with the grid. As well, you'll see now in the dynamic model property window, you have the inputs for this particular structure, as well as the resulting outputs. So based on this configuration here of a 20-meter wide crest, 3-to-1 downstream slope, 2-to-1 upstream slope, this crest elevation, this shell height, these are your volumes. And this is dynamic now. I want a 50-meter wide crest. I can change that and I'll update my design. I want this 4-to-1, 3-to-1. Notice as I'm making these changes, it's updating the footprint area, it's updating the dam volume as well. I can generate the footprint of this layer. And that will also be dynamic. The line work's dynamic, the surface is dynamic, as well as the outputs. Beyond that, you can manipulate the line work and change the configuration of your topography. So I'm just going to make my grid a little more transparent so I can see my line. Then if I move this line around, it will redigitize the dam. So I'm going to go to polyline. Move point on line, select my line, change the alignment, move my dam around, and also add a point. So that's, you can make changes after the fact. You can make changes on that original, design line that you used and on the inputs. Go back and make this opaque. Okay, so I have my dam at 425 meters in elevation, but I'm curious, what really is the capacity here? How much volume can be stored in this area? Really, I think practical function is in the surface water tools here. You want to go to surface water, info, find maximum containment elevation. This is going to calculate, how much water, how much material that is sloping at 0% can be stored within this area. And it's also going to digitize that pond for you. So I'm going to hit find maximum containment elevation. I'm going to select my grid here, which has to be the merged grid with the dam built in. Otherwise, you don't have capacity. And I'm just going to pick a point of where the pond would sit. I'm going to go to work. Okay, so even though I have a dam built up to 425 meters in elevation, based on what I'm seeing in the output window, I really only have containment to 395.9999 meters. Now I'm looking at this surface, and this makes some sense here, namely because of this point right here. So the issue is I've run out of topography to the north. This point here is, at basically 396 meters in elevation. So if, there's additional material, it would just spill off this side. So that's why it doesn't work. I do still have capacity here against my dam, but I don't have capacity here. And if, and this would be the next point to go over here. It's also letting me know you can fit 23.153 million cubes in here. You'll also notice it created this pond surface with this beautiful water texture automatically. All right, so that's good information to have. 23 million cubes, and really I can only store up to 396 meters in elevation. Okay, I'm going to unload this. If I just want to build a pond quickly in this area, I go to structures, ponds, create pond surface. I want to put a pond up to 390 below my 396, a 3.5999 meter max. Ask it to calculate the volume. And then just select my grid and then select a point where I want the pond to sit. And once again, it will create that pond at that elevation, give me the surface area, and give me the volume. Another pond type to use would be a dynamic pond model. So I'm going to go into my dynamic model tools this time, ponds, and then I'm going to add a dynamic pond for volume. So it's going to link to this merge grid here with the dam built in, and it's going to add a dynamic pond model. Once again, I'm going to select a point in the pond. And you can see now in your dynamic model window, a new dynamic model has appeared, the pond. And right now it has created a pond for 1,000 cubes. So you can barely see it, but it's right there. And then I can update this value. Say, I want this to be 10 million. And it's going to redigitize the pond. I believe that is 1 million. This would be 10. Just quickly, you can enter in volumes, get surface area, get the elevation, or you can work the other way, enter elevations and get the volumes. If you have a dynamic model that you like, that you want to keep working with, you always have the option to save it, and then you can come to dynamic models and load it later, and then continue working like this. All right. I wanted to go through more dynamic structures, but I can see we're going to get short on time here. So I'm going to jump straight to deposition tools and run through some deposition here. Okay, so I'm going to save my merge grid with the dam built in. And I'm just going to clear everything else. And I'm just going to bring that merge grid back. Okay, so to begin, we're going to pour some tailings. So we need to define the tailings type. Okay, to do that, we go to the 𝐓𝐸𝐲 menu. Project, tailings database. Okay, right now I have no tailings defined. So I'm going to create one. Right click on tailings. I'm going to go new. I'm going to call this tailings type 1. I'm going to leave the densities as 1 ton per cubic meter above and below water. So volume and tonnage can be interchangeable in this case. But you can adjust these. And this is dry density. Okay, slope definition. You can define slopes above water and below water. Okay, so let's start with above water. You have 3 different options here. You can do straight linear. So the tailings will slope above water consistently at this number. 0.01, or sorry, 0.01. So this would be 1% slope. If it was 0.1, it would be 10% slope. Okay, otherwise, you can do it on a compound basis. So you have multiple slopes above water, depending on the distance from the discharge point. Okay, so let's say I want to put in a compound slope here. Right-click on this gray sidebar and add some rows. Let's try that again. I'm going to add some rows. Add 2 rows. Okay. So the first row is the first segment of distance from the discharge point. So I'm going to say for the first 100 meters, I want you to slope at 5%. Okay. Then for the next 200 meters. So really this is going to be 100 to 300 meters away from that discharge point. So first 100, 5%. The next 200 after that, 2.5%. And then following that 200-meter segment for the next 300 meters, 1%. So total here, I've defined 600 meters. Yes, I've defined 600 meters of distance from the discharge point, how I would like it to slope. Okay, so what happens beyond that 600 meters? That's defined here in final slope. So beyond that, and we're still above water, just, do 0.1%. Basically be flat. So that would be how you would define a compound slope. And then there's polynomial. Now this would be, you would enter in a function. So I think this would be used when you really want to recreate a very realistic projection of how your tailings are going to slope. So you would take, existing survey data of your tailings beach, and then you could drape a line onto your tailings beach, export that line, put it in Excel, and then do a scatter plot of, the incremental slope versus the distance from the discharge line. That would give you an equation, y being the slope, x being the distance from the discharge line. You would put that equation here in this polynomial function, and then, based on a specific distance, specific x, you would get, a y slope that would change dynamically as you advance away from that discharge line. So that could be, something that you could use if you wanted a future projection of your slope based on tangible survey data of how it exists now. In this case, I'm just going to do 1% linear slope above water and 3% linear slope below water. Okay, and I have a tailings type defined. Okay, next I need a discharge line. So I'm just going to start by drawing a line. This is at 425, but I don't really need to be pumping tailings from that high up given my capacity. So I'm going to draw a line at 397 meters. I'm just going to draw my discharge line here. If I want to use these, if I want to use a grid or a discharge line and deposition run, I have to make sure they're saved, since it's going to try to find them in my project directory. So I'm going to save this as discharge 1. Okay, now I'm going to pour some tailings. So I'm going to begin with a capacity model. So a capacity model is a situation where I want to figure out, what is the maximum amount of tailings I can store based on the elevation of a discharge line that I'm inputting. So right now I have my discharge line at 397 meters. I want to know, how much volume of tailings can I get at that elevation for a specific pond configuration that I'm going to give you. Okay, so I'm going to go to 𝐓𝐸𝐬𝐬, single stream deposition, fixed pond elevation, as drawn. So these are capacity models. This is the most common one, as drawn. My base grid is going to be my merge grid. Discharge points are going to be the line I just drew. Discharge 1. I'm going to choose tailings type 1. I'm going to target a pond elevation of 390 meters. So I'm going to say, I want you to pour all the tailings you can up to this discharge line based on the tailings type that I've defined and make a pond at 390 meters in elevation. I have to enter the maximum containment elevation. I know from earlier that is maximum 395.9999. So I'm just going to put in 395.99. And then that's all I need to do. Hit OK. Pick a point in my pond where I want to pour the tailings, where I want the pond to exist. Let it go to work. Okay, so the deposition run has completed. You can see here, you now have a new surface and new layers created. Let's just go through them quickly. Okay, 1, the output grid. So every time you do a deposition run, it's going to create an output grid. This is going to be your merge grid with your dam structure or whatever structures you have built in, plus the tailings. The discharge points, which is essentially your discharge line, is also going to get created. An outline of your tailings where it exists on that output grid gets created. A pond surface with that texture applied gets created, the outline of it, and the pond location, which is your low point. in your topography. So the low point would be right there. Okay, let's take a look at this output grid. Let's do a little post-processing quickly. I'm going to go to my ooze menu, texture. I want to color this tailing surface so it stands out a little more. I'm going to keep the rest of the surface white and the tailings can be yellow. All right, so I can see my tailings. I can see it above water, and I can see it below water a little better. Okay, let's take a look at the contours here. I'm going to go back to ooze, contour tailing surface. Do 1 meter contours. Okay, so this gives me one, you can see the difference in slope above and below water. It's sloping a lot harder, 3 times harder, 3% below water. See, there's a question in the chat. I will read that after, sorry. Yeah, you can see you can see the slope here. You can see the 1% slope versus the 3% slope below water. Maybe more importantly in this case, what I'm trying to display here is you can see the discharge points, where the tailings was discharged. You can see that it was discharged from here and from here. That's because I used a discharge line that I just quickly digitized as a polyline using the polyline function. So when I drew that discharge line, I made 2 points, and those 2 points is what it's using for discharge points. So really, although I drew a line that goes across the entire crest of the dam, there's really only one discharge point here and one discharge point there based on how I drew it. Okay, if you want to draw a discharge line where you have spigots that are evenly spaced, we could do that in a different way. So I'm just going to clear my graphics. Bring back my merge grid. One thing I should note is those files created from a deposition run, they're automatically saved. You can see the output grid is still saved in my base directory. If you want to draw a discharge line with regularly spaced points, go to ooze, discharge points, draw regularly spaced discharge points. I'm going to put this one again at 397 meters, and I'm going to put a discharge point every 100 meters. Now I have the option here to keep drawn points. So this is the option to, when you're drawing the line, do you also want a discharge point at the points that you're digitizing when you draw it? Or do you just want them every 100 meters? In this case, I just want them every 100 meters. Don't take into account the points that I'm digitizing when I draw the line in terms of discharge points. So I'm going to unselect that. I'm going to draw this again. The only thing you want to do here is, draw your discharge line above the topography, so in the area that is shaded, and roughly at the X and Y location of where it would exist. That's kind of where a line at 397 meters would sit on the topography. Base that 397 meters is like right there, but it's still above the topography. Here's how my new discharge line. I'm going to once again save it. I'm going to call this discharge 2. I'm going to run that same deposition just with the new discharge line. Right click, as drawn, last value for all fields, and then just change the discharge line. Hit OK. Take a point in the pond. Let's color that tailing surface again. Contour it again. All right, now you can see the difference in terms of the contours, where you have, an even beach along the top because you're discharging at regularly spaced intervals. Okay, so probably more importantly, the information from the deposition run. Okay, so you can see here, There's a summary of the results from that run. It's letting you know, one, your pond as input is at 390 meters, and that results in a 2.49 million cubic meter pond volume. Beyond that, this is its area. In terms of the deposition, the discharge elevation here, this is the maximum elevation of the tailings. So in this case, because we're running a capacity model, where we want to pour up to exactly where that discharge line is, that's the maximum elevation. That's the contact point between the tailings and the dike, 397 meters. It resulted in 15.4 million cubes of tailings being deposited. In this case, tonnage and volume is interchangeable because of the dry density of 1, and it gives you the split above and below water. So a little deceptive here. If you were just to look at it, you would think there's significantly more tailings above water than below water. But because of the sloping, 13 million cubes below water, 2.4 million above water. You have this thickness percentiles, the average thickness, the maximum runout distance. And this is one way to define, the 3D geometry of your TSF. If you go to the 𝐓𝐲 menu here, go back to single stream deposition, you can see you start by defining essentially how you want your pond to be. Do you want no pond? Do you want to have an elevation of your pond that you're trying to target? Do you want to have a volume? Do you want to have a fixed pond area? And then from there, you can kind of move on to what type of deposition engine do you want. Do you want to do a capacity model where it's going to let you know what the maximum amount of volume you can place, or do you want to do a scheduling model where you're going to input a volume or tonnage of tailings, and then it's going to give you, what beach elevation you're dealing with. Okay, so let's take a look at a scheduling model. Okay, so once again, I'm going to clear my screen. Put in my merge grid and take a look at a fixed pond volume. And I'm going to do flow path down slope. For my base grid, I'm going to pick the merge grid here. My discharge points, I'll use discharge 2 with the regularly spaced discharge points. My initial discharge elevation will be 397. That's where, the line is sitting. So I'm telling the software, assume you're pouring from 397. In terms of tonnage, I'm going to do 12 million cubes, or 12 million tons, cubes interchangeable. You don't have to worry about the maximum elevation change. This is just dictating how it's going to step through different iterations. And I don't need to consider a vertical offset from the flow path. I'm just going to assume that the tailings is being poured down the topography, that there's nothing in between. The initial pond elevation guess, I'm just going to put in 390 because that's, I know that's a possible elevation. And for the pond volume, I'm going to target a pond volume of 3 million cubes. And I know that my maximum containment elevation is just below 396. I'm just going to say 395. Hit OK. Pick a point on my pond. Let it go to work. Okay, so it ran through a few iterations, but finally came up with the final results here. So my pond ends up being at 388.31 meters in elevation. It hit almost 3 million cubes exactly, 2.993. I can see my pond area is about 500,000 square meters. It turns out that although my line is at 397, based on the 12 million cubes that were input, the maximum elevation ended up being 393.625. So it didn't need to go up to 397. There's still some extra room there given the 12 million cubic meter input. And then I have my splits above and below water. So that's essentially the difference between a capacity model and a scheduling model. The most common capacity model is as drawn. And then on the scheduling side, if you just have, volumes of tailings that you're trying to input, a flow path downslope is always a good one. But we can look at another one quickly here. So I'm just going to create another line. Put this at 600 meters. So it floats above topography. I'm going to put it right there. Let's save this new line as user flow path. And I'm going to close down all these other layers. I'm going to open back up my merge grid again. Okay, so we've been drawing discharge lines and depositing tailings kind of, perpendicularly from those lines. So it's coming from the line. In this case, we're going to do a deposition model where the tailings is going to follow the direction of the line. It's called user flow path, so a little different. So I'm going to try to pour tailings from here towards the dam and see how this looks. I'm going to go to ooze, single stream deposition. I'll do fixed pond volume again and user flow path. Once again, base grid is going to be this merge grid that I'm looking at. My discharge points this time is going to be this line that I drew. Initial discharge elevation, I'm just going to say 397 again. Tonnage, let's try to put 10 million cubes. My pond volume, I'll do our initial pond elevation guess. So you need to kind of guess where the pond will be. It doesn't have to be that close, but I'm going to guess 390 again. My pond volume, let's do 2.5 million cubes. I believe that's 2.5. Max contain, I'm going to say is 395. Hit OK. Pick a point in the pond. Let it go to work. Okay, so a bit of a different configuration here. You can see it did pour the tailings from this side, and then, had no choice but to place the pond here. Probably not an ideal configuration, but, different tools to use if you want to simulate deposition. Okay, one more before we go. I'm just going to put a single point discharge here, use the vertical delta deposition tool, and take a look at that. Okay, my graphics again. Reload my merge grid. Okay, so I want to put a single point discharge. I'm going to put it right here. Okay, so I want to point right there. So I'm going to float over my topographic surface. I'm going to hit C, take those X, Y, Z in coordinates, go to data import, text data, paste points from clipboard. So I'm pasting the coordinates of that point. I'm going to call this discharge point. Okay, this gets a little confusing here. If you want to use, even if it's just a single point that you want to use, you have to save it as a line. So if you want to use, a feature as a discharge line, it has to be a line, not a point, even if it just has one point to it. So this is essentially just a line with one point. But you do have to remember to save it as a line, otherwise you won't be able to load it into the deposition engine. I'm going to hit OK. I'm going to save my discharge point. I'm going to run this again, but just discharge from this singular point. And for that, I'm going to use ooze single stream deposition. Once again, I'll do fixed pond volume. and I'll use the vertical delta deposition engine. So I think this is a really practical engine to use if you have these single points. It ignores that Z, the elevation on the point, and just kind of floats it up and down in X and Y, and then finds the appropriate elevation to discharge from. I'm going to choose this merge grid again. I'm going to find that deposition point, discharge point here. Let's say once again, let's start at 397. Tailings tonnage. And I will do a pond volume of 1.5 billion this time. Maximum contain is still just a shade under 396, but I'll say 395. And then just run this again. All right, so there was an issue with, I believe, the pond elevation. 395, 395.6. Let's try that again. See if 380 helps, or if I'm going to be going the wrong way. See if that helps. I'm just automatically fixing discontinuity areas to see if that kind of forces this through to make it work. So just having a bit of a tough time figuring out the configuration given my inputs. But it did get there. The issue likely being this insufficient pond volume of 1.5 million. It was probably tough to fit in. What I did there was I selected to automatically fix deposition errors. So when the software does encounter, issues kind of building that 3D geometry, this kind of, forces it through and helps you complete your deposition run. I would advise trying to make things work without having that checked. And if you encounter issues checking it, in this situation, press for time. So just wanted to see the end result. Okay, so you can see here, ended up having quite a small pond at 1.5 million cubes based on all the tailings that was placed in the topography, 385 meters in elevation, and, a maximum tailings elevation of 395.608, even though that point was kind of assumed to be floating at 397. So let's just take a look at this tailings quickly here before we go. Just going to texture it again, because I think it helps visibility. Color that tailing surface. Contour it. That kind of gives you a good idea of how it was deposited. So centrally from this point, and then float out from there, as to the other, as opposed to when you have a discharge line, it's coming, from that discharge line. Okay, well that takes us 5 minutes above time. I would like to thank everybody for joining me today. There was a lot more, dynamic structure modeling that I wanted to get into, but um, kind of ran out of time. Could probably kick that into to another lesson where we do more dynamic structure modeling, more deposition runs, maybe start to get into multi-stream. If there's content that you guys want to see, please feel free to reach out by email, sam@muck3d.com, or on LinkedIn, or however you'd like. And yeah, we'll try to do these on a semi-regular basis. And yeah, let me know kind of what you guys would like to focus on, and we can take it from there. So thank you, and have a nice day. I'll just check the chat quickly here. Can you cycle through different discharge points over a given time volume? Yeah, you can incorporate temporal components. You can do different discharge points at different times, different ways of doing that. It's definitely possible. Okay, sequencing. You guys want to talk about sequencing, and you guys want to talk about timing. So you want to take your production schedules and put them into the software. Understood. So we can take a look at that in future iterations. Does Muck incorporate 10 out of 100-year flood events for pond volumes as well as freshness events for northern communities? Uh, yeah, there's a lot you can do. You can incorporate storm events. Um, you'd have to do that numerically, in Excel or GoldSim or something like that, and then input that in. You can always just add a pond surface to this. Okay, I think I understand what you guys want. Where can we find the record for future reference? I will email out a link to the video. I'll also post it on my LinkedIn, so you guys can watch this at your discretion. And thank you, and have a nice day.